Imagine stepping onto a highly sensitive scale inside a snowy Canadian igloo. Now, instantly teleport onto a boat bobbing in the Indian Ocean. Look down, and the dial has actually ticked backward. You weigh less. You haven't miraculously lost water weight or burned fat. The literal earth beneath your feet is pulling down on your body with slightly less force. You can forget what high school physics taught you. The idea that Earth's gravity is a perfect, constant 9.8 meters per second squared everywhere on the planet is a convenient fiction. This animation shows the real story. Gravity is determined entirely by mass. A perfectly smooth, dense sphere would have perfectly uniform gravity, but Earth is highly irregular. If a specific area of the planet has less physical mass, it generates a weaker gravitational pull. To figure out where that missing mass went, we have to look down. We are going to peel the planet back layer by layer, starting right at the surface and digging all the way to the core. Layer 1 is the surface itself. Every day, the Earth completes a full rotation, and that spin generates centrifugal force. This cross-section illustrates exactly what that motion does. As the planet rotates, its mass is forced outward. This stretches the midsection, creating a physical bulge right around the equator. Because of that equatorial bulge, standing on the coastline of Sri Lanka means you are physically sitting further away from the Earth's dense center. That tiny bit of extra distance causes a slight measurable drop in local gravity. But being slightly further from the center is a minor local effect. To find a true gravity hole, we have to break ground and dig directly into the crust. Welcome to Hudson Bay, Canada. Since the 1960s, scientists have known this seemingly quiet, rocky landscape harbors a massive regional gravity anomaly. The culprit is dead ice. During the last ice age, a massive glacier known as the Laurentide ice sheet sat heavily over this entire region. Its immense weight physically crushed the solid rock crust downward into the Earth. This diagram outlines a mechanical process called glacial isostatic adjustment. The heavy white block you see represents that ancient glacier. It melted roughly 10,000 years ago, and ever since, the deeply dented crust has been slowly rebounding upward, like a slow-motion trampoline. But watch the layer underneath. While the surface crust arches back up, the heavy, dense mantle rock beneath it has not yet flowed back in to fill the massive underground void. That empty gap means the region lacks mass, creating a vast weak spot in the gravitational pull above it. Dead ice sheets leave dents large enough to weaken regional gravity. But the most extreme gravity deficits force us to plunge entirely past the crust, straight into the deep mantle. This brings us to the boss level of gravity holes, the Indian Ocean Geoid Low. This topographic map shows the sheer scale of the anomaly. Spanning roughly 3 million square kilometers southwest of India, the gravitational pull here is so weak that the physical surface of the ocean drops 106 meters lower than the global average. A 2021 study finally traced the origin of this massive deficit to a deep underground disturbance thousands of miles away called the African blob. Eons ago, an ancient piece of Earth's crust known as the Tethys Plate fractured apart and violently sank deep into the Earth's mantle. As that massive slab of heavy rock plunged downward, it forced plumes of intensely hot, low-density magma to shoot upward. Those rising, lightweight plumes physically pushed out the heavier, denser rock sitting directly beneath the Indian Ocean. By replacing dense rock with low-density magma, the Earth lost an enormous amount of underground mass in one concentrated spot. That hidden deficit translates entirely into the largest drop in gravitational pull anywhere on the planet's surface. Gravity operates as a living X-ray. It maps out a violent hidden history, happening thousands of miles beneath our feet. Your exact weight on a scale right now is a direct measurement of the ghosts of long-dead ice sheets and sunken tectonic plates floating in the deep. We have successfully mapped the Indian Ocean Geoid Low, yet the deep mantle remains vast, constantly boiling, and entirely unexplored. If a graveyard of ancient rock can create a 3 million square kilometer gravity hole hiding in plain sight, what other massive invisible anomalies are shifting deep beneath our feet right now, waiting to surface?